Good morning, students. This is Mr. Mills again, and today we'll be looking at Unit 1, Lesson 6, Combining Like Terms. We have two lesson objectives for today, so let's look at them before we get started. First of all, students will be able to identify the parts of an algebraic expression, including variable terms, constant terms, and coefficients. The second one, students will be able to simplify algebraic expressions by combining like terms. All right, so let's get started. So first of all, let's look at the expression 7x plus 3 minus 5x plus 8 plus 4x minus 1. Let's look at the parts of that expression. Well, first of all, we have variable terms. Variable terms are terms with a variable or a letter, if you want to think of it in that way. In the example above, 7x, negative 5x, and 4x are all variable terms. Notice that we had to pull the sign with that 5x to make it negative 5x. Constant terms are terms without a variable. In the example above, 3, 8, and negative 1 are all constant terms. Another vocabulary term here are coefficients. Coefficients are numbers next to the variable or next to the letters. They do not have a plus sign or minus sign between them, speaking of the number and that variable. In the example above, 7, negative 5, and 4 are the coefficients. All right, so let's look at an example. Name the parts of the expression 7p minus 1 minus 9p plus 5. Identify the variable terms, constant terms, and the coefficients. So let's look at our variable terms first. So variables have the letter, so we have the 7p and the negative 9p. Constant terms are numbers that don't have letters on them. So we have the negative 1 and the positive 5. And then finally, it says the coefficients. So the coefficients are the numbers next to the letters. So we have the 7 here on 7p, and we have the negative 9 there for negative 9p. All right. Now, what does it mean to combine like terms? Combining like terms means to combine common variable terms and constant terms. Okay, they said, well, what does that mean? So let's look at an example. Simplify the expression below. So you have 7x plus 3 minus 5x plus 8 plus 4x minus 1. We're going to put our common variable terms. So variable terms that have the same letters. I like to say sometimes they have the same last name. So notice here, and I tried to do this with the color coding since we're doing it on the slides, you have 7x, negative 5x, and positive 4x. All of those have the same variable, which is x. It's important that we see that it has the same variable, and it's to the same exponent. You don't see an exponent, so it's understood to be a 1, but we'll see that a little bit later on in the presentation. Then I'm looking at your coefficients, not your coefficients, your constant terms. You have positive 3, positive 8, and negative 1. Those are the numbers without variables, so they will be put together as well. So 7 minus 5 is positive 2, plus 4 is 6x, and 3 plus 8 is 11, minus 1 is 10. So our answer in this case will be 6x plus 10. And we cannot put the 6x and the 10 together. Why? Because they don't have the same last name. They don't have the same variable. They're not common variable terms. Okay? So you have an x on the 6x. You can't put that with just that simple 10. All right, so let's look at some examples. 3x plus 6x. You both have the linear term, the x there. So 3 and 6, we're just going to add the numbers. We're not going to add the exponents, and that's going to be 9x. Another example, 7p minus 1 minus 9p plus 5. We'll put the p's together. 7 minus 9 is negative 2p, and negative 1 plus 5 is a positive 4. One more example on this screen. 5x plus 7y minus x plus 2y plus 3x. Now notice here, we have two different kinds of variables. We have x's and y's. So we're going to have to treat them separately. We're going to put all the x's together. So that's the 5x, the negative 1x, and the 3x. Remember, if it's no number there, it's understood to be a 1. And then likewise, we're going to put together the 7y and the 2y. So when we do that, we'll get 7x plus 9y. But we can't put those together because the x and the y don't have the same last name. You're right. Combining like terms with exponents. Okay, I want to make sure you see that. Combining like terms with exponents. All right, so the rule here is terms with the same exponents for a combination of variables and exponents are considered like terms. When combined, be sure not to change their exponents. So what do we mean? Let's look at an example. We have 8c cubed minus 7c cubed plus 16c cubed. All of those are c to the third power. So they're the same last name. So we just look at the coefficients, the 8 minus 7 plus 16. That's what we put together. And when we do that, we're going to have 17, I think, c cubed. Let's see if I'm right. Yep, that's it. Okay, notice we didn't add the 3, 3, and 3 and get c to the ninth. It stays c to the third power. So when you're adding like terms with exponents, you do not, I repeat, you do not add the exponents. You don't change them. Let's look at another example. X squared plus 2xy minus 7xy plus 4y squared. The x squared is by itself. The y squared is by itself. The only thing that we have anything in common is a 2xy and a minus 7xy. So 2 minus 7 is negative 5. So the first one doesn't change. We'll have minus 5xy, and then the 4y squared on the end is not going to change. All right, last example. So we got a lot of terms going on here. Notice we have x squareds, we have x's, and then we have just the constant terms. So 4x squared is going to be put together with the negative 3x squared. That gives you a 1x squared. 2x and 8x is going to be 10x. Negative 7 minus 6 is going to be negative 13. Yes, glad I got that one right. I wasn't sure for a minute. All right, let's keep going. This can apply to geometry too. So, okay, well, I hadn't had geometry yet, but you will, and you'll see algebra in it. It's everywhere, baby. All right, so directions. Give the perimeter of each figure as a simplified expression. So let's look at this triangle. 2x plus 1 on one side, x on the other, and then 3x at the bottom. Well, perimeter means to add all the sides together. So now this is a problem just like what we had previously. So it's just 2x plus 1 plus x plus 3x. We're going to put our like terms together, which are our x values. 2, 1, and 3 is 6. And then that constant term is there by itself. So it's 6x plus 1. Let's look at one final example. Give the perimeter of each figure the simplified expression. All right, here we have a rectangle. So how do we know it's a rectangle? You have 4 right angles. You'll see this more in your geometry class. But just here's the thing that matters. Because you have those 4 right angles, those boxes in the corners, opposite sides are going to be the same. So this is y plus 2. That's y plus 2. This is 3y minus 5. This is going to be 3y minus 5. So perimeter means to add all the sides together. So we're going to have to add all 4 sides together, not just the 2 sides that they have labeled. So you have the 3y minus 5 plus the y plus 2. And then we have those 2 that I alluded to that are going to match up on the opposite sides. So when we put our y's together and we put our constant values together, what we'll end up with is 8y minus 6. So you have several examples. Want to make sure if you haven't got all of those in your notes, go back and put them in your notes. And let's get started on the practice, and we'll see you in the next video.